and thank you for the warm introduction. So as he said, I got 20 years of experience in the air conditioning industry, but I consider myself as a student of air conditioning. So I don't feel bad of saying I don't know. So you can ask any questions. I may say I don't know, but I'll help you and guide you to find the answers. So that is the vastness of this industry. So feel free to interrupt any time on this discussion to ask any questions. So it will be more interesting for me also if you interrupt and ask questions. Like Sadish said, to teach youngsters is more difficult because they have the basic nature of asking doubts, which is the fundamentals. And most of these questions are the reasons of leading into further expansion of the industry. So the basics is very important, and this will help people who like us, who always take pride that we teach so many people. But when we start preparing for students, we realize that some of the fundamentals is still questionable, and these questions will lead to further improvement in the industry. So with this kind note, I'd like to start the class. So like when we were started discussing how this course is based, so Sadish was telling me that it is from known to unknown. So first I thought it is very simple, but when I start realizing to explain something which is unknown to somebody by using his known or her known things is very difficult. Or in other way, that is to explain a complex items with the basics of knowledge. So actually it helped me to open my eyes about the basics of air conditioning, and which is helping me to understand more about the air conditioning. So before explain about the air conditioning, I like to explain the importance of air conditioning and what is air conditioning and why it is very important for the mankind. So air conditioning is actually about managing the air. So air contains gas and vapors. So managing the pressure, temperature, and the vapor content inside the air, that is air conditioning. So if we can control various properties of the air, we can create our necessary conditions wherever it is required. So today, human beings are born on Earth, but we are not supposed to be dying on Earth. The mankind will move away from Earth and settle at various places. Maybe Mars, maybe Moon, maybe anywhere in the universe. So air conditioning is very important for this because people asked to live on these places. The air they live or the place, the ambience where they live has to be get managed. Similarly, on the produce, medicines, all these are produced or manufactured at certain location. It has to move to various parts of the world, various parts to reach various difficult places to reach over a period of time, maybe many months. This has to be preserved for its quality. So food preservation, medicine preservation, transportation, to getting to the people's, to enriching the people's life, the air conditioning is very important. So basically air conditioning helps people to live happily, enrich their lives and enrich the quality of the life, reduces poverty, increase the overall mankind's efficiency in their lives and have a better life. That is what air conditioning does overall to the mankind. So all our growth is directly proportionate to the air conditioning in a way, because today we are living in skyscrapers, we are living in under the earth, in space stations. All this happens because we are able to manage the air. We were able to move food from wherever it is produced to the place where it is less produced, where famines are there, where natural calamities are there. Medicines produced at one part of the world is moved to rest of the world. Vaccines, COVID vaccine, which we as a best example, produced at Pune, spread across all over the world. All this was possible because we were able to preserve it, maintain the temperature around these vaccines, around these things. That is why the air conditioning is very important. Now, when it comes to the job part, which is very important when we talk to people, when we talk to the parents, will the air conditioning or these things is important for to get a job? The world is changing very fast. The technology is changing very fast. So people are afraid to learn something because they may feel that whatever I'm learning today become obsolete in the future. So I just want all the students to take a deep breath, hold it, release it. Take one more deep breath, hold it, release it. Now just think, breathing is not a choice. You have to breathe. Every living organisms, every human being has to breathe. As long as people needs to breathe, air conditioning will be there. It's all about managing the air, the quality of the air, properties of the air. So air conditioning is a future-proof part into the life of mankind. The technology of managing the air may change, new developments will come, but the fundamentals of what air conditioning does, that like managing the properties of the air, that remain intact. So yes, learning about air conditioning is always worth enough to get a job. So that is the other side of air conditioning. With this part, I like to start with the basic concepts known to unknown. So let us move to the most important place in our home, that is kitchen. So kitchen is a place where we actually use heat energy to change the properties of many things, vegetables, cooking vegetables, meat, produce many things in the kitchen. So the most important aspects in the kitchen is heat energy or the fire. We use fire to do many activities in the kitchens. The fire or the heat energy, that is the basic concepts which we are coming into air conditioning. So in the kitchen, first let us try to make a cup of coffee. I hope everybody likes coffee.
Yes, sir.
Good. So for making coffee, basically we need very few items: water, coffee powder, if you like milk, milk. From our point of view, our this class point of view, heat is we consider the most important aspects, and a utensil. So to make a coffee, we take water into a utensil, put it into the fire. Make sure that you have your parents with you when you're lighting the fire. Keep the pot for some time. The water temperature changes, it starts boiling, add coffee powder, we get a coffee. So this is what the basic things which you can observe in the kitchen. Now when you look deep, what is happening in this thing? What happened? From a energy point of view, temperature point of view, the water temperature at the beginning of making the coffee was comfortable because you were taking water from the taps or from the filter. The pot temperature, you were handling it with your hands, but fire was very hot. After some time, the water become very hot, the pot become very hot, the utensil become very hot. You need an external device to hold it. The fire temperature remains same, more or less. The temperature of water moved from room temperature 26-30 degrees Celsius all the way to 100 degrees Celsius. So this is from the start of making a coffee to the end of making the coffee. So this is what is everything about the air conditioning, what we are trying to do. How the energy is moved from lower temperature to higher temperature, or how we manage it. So what happens with fire? Fire is like all of us. We all likes to move. We like to go to zoo. We like to see places, shopping malls. We like to move. Human beings likes to move. Fire is also same. Fire likes to move. It likes to travel from one place to other. It needs certain medium to travel. It does not travel through vacuum. It needs a medium. It needs certain things to burn. So fire moves from other. So what fire? The heat energy also needs a medium to move from one end to other end, and it keeps moving. How it moves? It it moves from hot to cold always. How heat energy moves? It has three ways of moving. Directly when the utensil was on the fire, the utensil got heated up. So that is called conduction. Directly the fire is in touch with the utensil, it get heated up because fire was at a higher temperature, utensil was at a lower temperature, it got heated up. The water at the bottom level first heats up, then this water moves up, the cold water comes down. So there is a movement of water in the pot. So that is called convection. It moves the hot energy, the molecules which get heated up moves from hot point to the cold point and comes back. So that is a convection. The third one is radiation. So when you keep your hands close to the utensil without touching it, you can feel the heat. You don't need to touch it. You come close, you feel the heatness. That is the radiation. It passes through the air, wherever it is, it passes and you can feel the heatness. So there are three ways the heat energy moves. These are the only three ways the heat energy moves in the system. So three ways: conduction, convection, radiation. The energy always moves from hot, higher temperature to lower temperature, or hot to cold. There is a one way of movement only. Heat energy will not flow from cold to hot. It's always move from hot to cold. That is the reason when we keep the utensils on the fire heats the water and the utensil, not the other way around. The fire temperature does not reduce. It's always move from hot to cold. Now comes to air conditioning. So here we see a difference in the thing. When we go outside our house, it's very hot. Our ambient conditions are much more hotter, but inside our house is already colder compared to outside. So outside may be 40 degrees Celsius, but inside will be 35, 36 degrees Celsius. So in this thing, we have a problem because to keep the air conditioning or to further reduce the temperature inside the room, we may need to move heat energy, which is at a lower temperature inside the room, to a temperature outside, which is a higher temperature. So we need to move energy from a low temperature to high temperature. But we always know energy flows from hot to cold. So naturally, from outside hot temperature to inside the room, the heat energy will be coming in. From room to outside, naturally, it cannot move. So we need an external force to move. We need an external force which will move the heat energy inside the room, which is at a lower temperature, and push this energy to outside, which is at a higher temperature. So that is what the air conditioning does. That is what the refrigeration does. It moves heat, or it absorbs heat from a lower temperature and try to release this heat to a higher temperature, which is outside the condition, outside the closed, enclosed. In our case, from a room to an outside ambient conditions. So something has to carry the heat. Heat will not move freely. So what carries the heat? So the example we can see is like human body is considered as one of the best air conditioning device. Our body adjusts our heart pumping capacities, the movement of the blood flow, everything to maintain the temperature of the body. So in the winter condition, our skins will become dry because all our sweat glands are closed. There is no evaporation will happen. But in summer season, all these glands will open and we evaporate, we sweat, and the evaporation happens and our body temperature cools down. When we do run, when we play, when we do exercise, our heart rate increases and we sweat. So our body maintains the temperature. So inside our all our organs are maintained at a constant temperature by varying the flow of the blood inside our body. So like blood, what it does, it circulates through all the muscles and all other part of the body. In air conditioning, we use something called a refrigerant. Refrigerant is a liquid vapor combination. It's in two phases. So it moves between the inside the room and outside the room. It comes inside the room, it absorbs the heat, it goes outside and releases the heat. So it is a continuous process of movement of refrigerant in a closed loop. It goes inside, comes out, and goes inside, comes out, carrying the heat. So that is what it does. So in this case, what our heart does, heart pumps and moves the blood across the body. So in air conditioning, we use something called compressor. Compressor is a motor. It's like our motor, what we uses for pumping the water. Normally, when we pump the water, it takes the water from the well or from the tanks and move into a different place. In this case, it's a closed loop. It takes the water, or it takes the refrigerant, moves to outside part, then it comes back to the inside of the room, and it keeps rotating into that. So that is what the compressor does. And compressor motor, it also helps the refrigerant to change the temperature and pressure. So that we'll see in the coming slides how the system will do that. So the air conditioning, if you see, you can see two parts. It divided into two parts. Whatever the type of air conditioning in the world, it has got two parts. One part is what we call inside the room, other part will be outside the room. These two parts will be connected through refrigerant. Refrigerant can be chemical things, it can be water, it can be carbon dioxide. There are various types of refrigerant. So it's a medium which carries heat from inside the room to outside, and then it comes back to carry more heat or more energy from the room. That is called a refrigerant. So refrigerant carries heat from room to outside the room. Compressor helps to circulate the refrigerant, and compressor also helps to increase the pressure and temperature, which is necessary for increasing the temperature.
Excuse me, sir.
Yeah.
So what is the best and safest kind of refrigerant? Means among them, which is the best?
Base and safe refrigerants. Natural refrigerants are there. Carbon dioxide is a natural refrigerant which can be used as the best thing. And there are various natural refrigerants are there. So you may be hearing a lot of things about global warming and linkage to refrigerants and other things.
Yeah.
So currently, most of the refrigerants add something called like global warming. So these refrigerants, when released to atmosphere, it get accumulated at the higher levels of atmosphere near the ozone layer. Some of the refrigerants actually removes the ozone and actually consumes ozone and convert ozone into different molecules. So that protective ozone layer is getting damaged. So till now, or as and when the world was using air conditioning, we were using synthetic refrigerants was there. But now the world is changing into natural refrigerants. So propane is there, carbon dioxides are there, and quantity of refrigerants are coming down. In some cases, even water is also used based on the temperature requirements. So there is no ideal refrigerant per se. The reason for that is the need of different. Sometimes the air conditioning may be used for comfort application, like what we use in our rooms for human comfort. But when we use for refrigeration, like keeping the ice creams, which is kept at minus 18 degrees Celsius, sometimes ice creams are manufactured at minus 30, minus 36 degrees Celsius. Some frozen foods are kept at minus 70 degrees Celsius. And when we see rocket propellants, which is used for sending satellites and other things, where the oxygen or sometimes hydrogen, all these are kept at minus 200 degrees Celsius. So all these needs different kind of refrigerant. So there is no ideal refrigerant, but the maximum used or maximum usage of air conditioning is for comfort application, and like our air conditioning what we use in our homes or in shopping malls, schools, other places. So these air conditionings are now getting or these air conditioners are now gradually shifting into more green refrigerant as what generally called green refrigerant is, which has less global warming potential. There is a word called GWP. So for example, we have a refrigerant called R22, R410. These are the namings of refrigerant. So that can be something which you can find it out what this R22, R stands for refrigerant actually, but there is a chemical composition also into that. So in further dividing refrigerant with chlorine and fluorine content, hydrochloro or hydrofluorochlorocarbons. So these are three different varieties which contain fluorine, chlorine, or fluorine and chlorine content. These kind of refrigerants are not considered as a good refrigerants for global warming part. So that is now gradually getting changed to much more natural, like carbon dioxide, which is coming up as a good refrigerant. Propane, which is another naturally occur refrigerant, which is a green refrigerant, coming up in this. So that will come up in the futures now. So coming back into that.
Thank you,
So
sir.
yeah, the air conditioning works in that. So we have to see uh, uh, what we see inside the room is always which absorbs the heat. What is outside is what rejects the heat. So when you go and stand behind the air conditioning, which is outside the room, you will always get a hot air. You can feel that hot air. Inside, you're getting a cold air. The compressor will be there in between, and expansion valve is a device which will be fitted inside, which may not be visible when you see the air conditioning into that. So what happens is like the refrigerant absorbs the heat, it rejects the heat, and the compressor compresses the refrigerant to increase the pressure and temperature. So when you heat a gas, it expands. It expands its volume. So when you compress the gas, it increases its pressure and temperature. So in an air conditioning system, we are not using an external heat energy source to increase the refrigerant temperature. We use a mechanical device which to compress the refrigerant to reduce its volume to increase its pressure and temperature. And this increased temperature will help it to give the hot air outside into that. So I'll explain in detail. Before that, I like to do a small thing. What happens when air? So just blow with your mouth open to your hands. You can feel hot air coming in. Now reduce your mouth, close your mouth like this, and forcefully blow it to your hand. So you can feel coldness. When you open your mouth wide and you blow, it is hot. When you close your mouth, reduce the one and blow, it is cold. So the same air which comes from your mouth, when it passes, become a high pressure, and when you blow it, you feel cold. When you without a pressure, when you just blow, it is hot. So air, by changing the pressure, we can increase the temperature of the air. It's a very simple experiment. You can feel it. Is hot, is cold. So this is the principle which we use in air conditioning by to increase the temperature. So when you pressurize the gas, when you increase the pressure, the temperature increases, and then from the high pressure, when you reduce the pressure, when you blow, increase the pressure, and you release the pressure, it becomes cold. So that is the property which we use. So this gas equation is there. Pressure volume is proportional to temperature. This is an ideal gas equation. The pressure and volume of a gas is proportional to its temperature. If you increase the pressure, the volume decreases. If you increase the pressure, and this is proportional measure. If you increase the temperature, it will proportionally change the pressure and the volume. So this is the basic equation which works in air conditioning. So this is what it explains. This is the slide this is the thing which I like to explain little more detail. We'll start from the compressor stage. So in the compressor, the pressure is increased, the motor, the gas which is there, it compresses the gas. It's like a piston which pressurizes gas inside a cylinder, which presses. Like when you try to blow air balloon using a balloon inflator, the same thing. When you pressurize, when you piston, when you press it down, it compresses the gas. The moment it is compressed, its volume is decreased and the temperature increases drastically. Now, before coming to that, just I like to remember the room temperature normally which we keep say here it will be 24 degrees Celsius, which is inside the room. So the air which is coming into the compressor as a refrigerant, the refrigerant which is coming to the compressor will be 24 degrees Celsius. But our ambient conditions, we can take it, say for example, 40 degrees Celsius. So to reject the heat to 40 degrees Celsius, the refrigerant temperature should be more than 40 degrees Celsius. Because heat energy always moves from hot to cold. So to reject heat to ambient, the refrigerant at outside of the air conditioning part should be more than 40 degrees Celsius. So what the compressor needs to do, the refrigerant which is coming at 24 degrees Celsius, it needs to increase the temperature of that refrigerant to more than 40 degrees Celsius. Then only when the refrigerant comes the outside part, it can reject the heat to the atmosphere. So to do that, the compressor, when the refrigerant comes to compressor, it compresses the refrigerant. When it compresses, the pressure increases, volume decreases, and the temperature shoots up. The temperature shoots up more than 40 degrees Celsius in example. So in that case, then this refrigerant moves from here to the outside area. The moment when it comes in contact with the outside area, the temperature of refrigerant is more than 40 degrees Celsius. So outside temperature is 40 degrees. For example, say refrigerant becomes 65 degrees Celsius. So from 60 to 80 degrees Celsius, the temperature moves from 65 degree to 40 degrees Celsius because it is hot, and the outside is 40 degree. Here it is 65. So our ambient is considered as colder compared to the refrigerant. So in this case, the temperature drops, the pressure remains constant. So when the temperature further reduces, the volume of the refrigerant further reduces. Inside, yes.
So what is that symbol like? It's shown right, like a half infinity.
Yeah, that is shown as proportionate symbol. It is just to show that it is proportionate, related. So
Sir, in my school, I learned that that symbol is known for alpha particle. Is it alpha particle?
yes. I just shown it to show us that it is proportionate.
Oh,
Not infinity. It is proportionate to. It is not equivalent. So because there is a constant come in between, the pressure volume is, we say, proportional to temperature, because to become an equivalent symbol we need there is a constant comes in between. So here, for explaining the air conditioning, I have not kept the constant part into that. We are just trying to understand the relationship between pressure, volume and temperature.
sir, one more question. Whenever we are putting the AC maximum, the cold temperature will be 16. Why isn't it below that? Like in my.
It can go below that because commercially available air conditioning, it is set at 16 as the minimum. That's all. It doesn't go below that. But if you can little bit tinker with the air conditioning, it can go below that also.
Oh, okay.
Okay. So if you have a thermometer, normal thermometer, what we use for checking the fever at home, and if you have access to the air conditioning, you switch on the air conditioning, wait for half an hour, and when where the air is coming out, you can see at some point the air will be coming out. Go closer to that and keep the thermometer at that place where the air is coming out. Don't put it inside, just in front of the air conditioning where air is coming out. And then wait for 1 minute and just see what is the temperature there. So that is something which you can see, and you can tell me what is the temperature you have observed of the air which is coming out of the air conditioning, just the outlet of the air conditioning.
Sir, I'll tell you in the next class.
Yes. So then you can see what is the temperature coming there, and that may answer some of the questions what you already asked me.
Oh. Like inside the room or outside the room?
Inside where the air coming out, you can just put it that. So
Okay.
your room temperature, you can take two temperatures. One is the with the thermometer, which is where you are sitting, which is far away from the air conditioning, maybe in the bed or the chair. After half an hour, take a temperature there, what is showing in the thermometer. Then go close, and where the air is coming out, keep it there for 1 minute and observe the temperature.
Okay, sir.
You see a difference into that. That explains why or what is the lowest temperature, what is possible in the commercially available air conditioning systems.
Okay, sir.
Okay. So back to this thing. So we were here, the refrigerant temperature, the compressor has increased the refrigerant temperature, increased its pressure, reduced its volume. So the temperature has reached for say 65 degrees Celsius, and the temperature, the refrigerant has moved to the outside part of the air conditioning system, where the ambient temperature is 40, but the refrigerant temperature is 65. So from 65, the heat energy moves to 40 degrees Celsius. So the refrigerant loses the temperature. So it reduces its temperature. Since the pressure inside the system remains constant there, the volume also increases because the pressure volume is proportional to temperature into that. Since the compressor, the refrigerant further moves from outside to inside the room where there is an expansion valve. So this is a device which we say which is a device which is throttling, what is called, where a pipe is there where the volume, where the cross section is reduced. It's like our mouth waveform. When you open the mouth, when you reduce like this, it reduces the volume. When it pushes the air through a small volume, it expands and it cools down. The experiment what we have seen here. So what expansion valve does is it reduces the available space inside the pipe where the refrigerant is moving. So when the refrigerant is moved through from a small hole, from a small volume to higher volume, it expands. So it cools down, like what we felt when we done the experiment. From a hot air become cool. The same way the expansion valve, when the refrigerant passes through that small orifice, small opening, after this opening, from till here, it will be hot. The moment it passes through here, it cools down drastically. So it loses the temperature to ambient temperature. Say from 65, it comes down to equivalent to say 45. When from here it expands, it comes down say 24 degrees Celsius. It reduces the temperature further. Say less than 24 degrees, say 20 degrees Celsius. This 20 degrees Celsius when comes into contact in the room is at 24 degrees Celsius. So the refrigerant is at a lower temperature. So from the room 24 degrees Celsius, the heat energy moves to the refrigerant which is at 20 degrees Celsius. It absorbs the heat inside the room and it goes to the compressor. So this is the cycle. So the refrigerant keeps moving in. So when it comes into the room, it is at a lower temperature. It absorbs the heat from the room. The compressor helps to increase the heat by reducing its volume, by increasing its pressure. And this refrigerant then goes to outside. It throws away the heat into the ambient. It gives away all the heat it absorbs inside the room, and what compressor has given to it, it gives the heat into outside. Then it comes back into the room. Then it expands the reduced volume. The compressor which has reduced its volume, it goes back to the old volume. So when it goes from a small volume to large volume, it cools down. It cools down to a lower temperature than the temperature inside the room, so that the room will become hotter compared to refrigerant. So from the hotter room temperature, which is at 24 degrees Celsius, the heat energy moves from 24 degree to say 20 degrees Celsius inside the refrigerant. Then it goes to the compressor. So this is the process of air conditioning. This is how the external force, which is compressor, which is helping room, which is generally at a lower temperature compared to ambient temperature, helps to move the heat energy from room to outside. So this is the air conditioning. This is the basic principle which is applies for the refrigerator, which is the basic principle which is applies where we keep our ice creams, which you see in the chest freezers, or what we see inside in shopping malls. The same device which uses, or the same principle is used to keep vaccines, medicines, food produce, other things. Now, controlling the refrigerant temperature, we can maintain different condition inside the room. Suppose if you want minus 30 degrees Celsius, we should make the refrigerant say minus 50 degrees Celsius, so that from minus 30 it can absorb heat and goes all the way to reject the heat at 45 degrees Celsius outside. So by maintaining the temperature of the refrigerant, we can maintain various temperature as per our requirement. So this is the basic principle.
Sir, even in the refrigerator, same rule.
In the refrigerator also same. So
Sir,
if
but
you
where do we feel the hot air?
in refrigerator, actually, if you go and touch, I mean, you just go and with a in presence of your parent, just see what is outside behind your refrigerator. Okay, some refrigerator behind you can see there is a small net mesh kind of thing, which is a copper, which is thing. So that if you touch with in presence of your parents, you can see hot. In some refrigerator, that is not visible. That is inside. If you just touch on the back side of that, if you feel hot, because it may not see a mesh, but it will be flat surfaces. But if you touch on the flat surfaces, it will be hot. Or if you can move the refrigerant, you look all the way down in the bottom part of the refrigerator, there can be a mesh. Somewhere on the back part of the refrigerator, there will be a hot point. So refrigerator is a very small enclosed space. So if you see, refrigerator is sitting inside the room. So inside the room is say already 24 degrees Celsius or a 30 degrees Celsius, and it is more or less remain constant. So it needs to reject the temperature at 30 degrees Celsius only, and inside it is say minus 4 degrees Celsius in the freezer and 4 degrees Celsius plus 4 degrees Celsius in the compartments. So
Yes.
it needs to move from minus 4 to 30 degrees Celsius. So we don't see a fan in the refrigerator to move the air. It moves. I'll go back to this part. See, here we learned something called convection.
Yes, sir.
So conduction, convection. So there is no air movement here. Like you see, the utensils, the hot water moves the thing, or the utensil get heated up and temperature moves through the metal. If you heat at one end of the metal, it moves other end, it moves the heatness, the heat energy moves. The similar way, we don't need a fan there. The temperature inside without a fan, because of the conduction and convection within that the air movement happens. It moves and cools without an external fan. That is why there is no air movement happens in the refrigerator, but the principle remains same of the same thing. One side is cold, other side is hot. That is there.
Thank you.
Now all this explained, there is one more activity actually which is happens with the refrigerant, because air or refrigerant without normal reducing the pressure, increasing the volume, reducing the volume, it is very difficult to carry a large amount of heat, because we need to carry a large quantity of heat from one end of the room or inside the room to outside conditions. What else will happening into refrigerant? That is the next part of that. To that, let us see what happens in a general water cycle. How we all learned about water cycle in earlier classes. So water gets heated up from the sea. So water changes the phase. From liquid, it becomes vapor. And the vapor moves all the way to the land masses or other thing. And the vapor then condenses. It converts back into water and comes down as rain or snow, and it flows back to sea. So this happened. So here if you see, the water changes phase. The phase, it moved from a liquid to vapor and then vapor to liquid. So this is called change of phase of the water. This is the same thing happens with the refrigerant. So the refrigerant changes phases. So for that we explained with the water side. The ice and water is at 0 degrees Celsius. If you take a thermometer and measure, the ice also at 0 degrees Celsius. The water also exists at 0 degrees Celsius. If you boil it, water boils at 100 degrees Celsius, and the steam which is coming out, the gas, the water becomes steam, that is also at 100 degrees Celsius. So water changes the phase. But what happens when the change of phase is happening? In change of phase, the temperature remains same, but the energy absorbed by the water is huge. So in earlier case also we told we need energy to be absorbed from the room and to be rejected outside. So we need change of phase to absorb a large amount of energy and reject large amount of energy. So energy is, to measure the energy, we need two parameters to be seen. The heat energy we can see is two part. One is called sensible heat. Sensible is in other way sensible, which is sense. We can sense it, we can measure it. A water at 0 degrees Celsius, we can sense. We put a thermometer, you can see 0. You feel pour water at your hand or something, it is 0 degree. Increase the temperature little bit, temperature become 40 degree, 30 degrees Celsius, we feel the hot water. So we can sense it. In sensible temperature, the temperature of the water changes. From 0 degree to 100 degrees Celsius, the water changes its temperature. So basically we can call it a sensible heat. Then another is called latent heat. The latent heat is where the temperature change is not, we cannot feel it directly. So if you put a thermometer in a boiling water, it shows 100 degrees Celsius, and the steam which is coming out will also be 100 degrees Celsius. Same with ice and water. Ice when just melts at then it is 0. Ice is also at 0 degrees Celsius. So water exists in both temperatures. 0 degree as water, 0 degree as ice, 100 degree as steam, 100 degree as water. But the phase changes. Water exists in, one is in solid form, one is in liquid form. One is in liquid form at 100 degree, one in gaseous form at 100 degrees Celsius. So the change of phase, that is called latent heat. So what happens in latent heat? The energy absorbed or energy rejected by the water for change of phase is huge. So ice is there, when it starts melting, it needs 80 calories of energy, say water and ice. The water exists. From 0 degree water to become say 100 degrees Celsius water, it absorbs 100 calories. From 0 degree water to 100 degrees Celsius, 0 degrees Celsius to 100 degrees Celsius, the water absorbs 100 degrees Celsius. But this same water at 100 degrees Celsius to become 100 degrees steam, it absorbs 540 calories of heat. So huge amount of energy is required to change the phase of water. These properties of liquid and vapor relationship, change of phase, or the latent heat of evaporation and latent heat of condensation, what we call, that properties are used in refrigerant to carry large amount of heat. So basically, if you see, if you have a small quantity of water which comes inside the room, it can absorb 540 degrees calories of heat energy from the room without changing in temperature, but by changing in phase. So water comes at 100 degrees Celsius, it absorbs large amount of heat energy, it changes to gas, temperature remain same, it goes out, and it can reject all this heat energy from 100 degree if it bring down to 80 degree, like that. So this change of phase is a property which we use in the refrigerant to carry large amount of heat from one side, one part of the room to outside of the room. So this is called latent heat. Now, latent heat, where it absorbs, where it rejects. When a let us take from a liquid to gas, it absorbs energy. Water absorbs energy to become gas. Similarly, refrigerant absorbs energy to change from a liquid phase to a vapor phase or gas form. From gas to liquid, it has to reject energy. So if you see in our refrigerant cycle, what you have seen, the refrigerant comes in this area, inside the room, it changes phase. The refrigerant changes from a liquid to vapor, so it can absorb a large quantity of energy. Then it goes to the compressor, get compressed, then comes here, it rejects the heat to become a liquid here. So the refrigerant is such a chemical, or you can say a chemical composition which can vaporize at a very low temperature and which can become a liquid at a higher temperature, little different from the water, because water become gases at 100 degrees Celsius, refrigerant become from liquid to gas at say 24 degrees Celsius, what is we keep in the room, example point of view. So that is the difference. So refrigerant properties are different. That is one of the reasons why water is not a good refrigerant. We cannot use water as a good refrigerant because water cannot absorb a large amount of heat at 24 degrees Celsius. We need other gases or other chemicals or other chemical composition things which can absorb or change phase at 20 degree or 24 degrees Celsius to change phase. Water is one of the abundant in earth, but just because water cannot change phase at a very low temperature, we cannot use water as a refrigerant in normal commercially available air conditioning. So water changes phase in the, and that property we use in refrigerant to absorb the heat from the room and reject into atmosphere. So let us understand that this is one of the additional properties what refrigerant does. So this change of phase, huge quantity of energy absorption happens here. And when you move from gas to liquid, this much energy is rejected. That is used in outside part where the refrigerant changes phase from a gas to liquid point of view. So this is what happens with the refrigerant. So refrigerant carries the heat, it changes phase, it comes back to the form and keeps rotating into various, we keep rotating between inside and outside.
So there are only two types of heat, latent and sensible.
Yes, basically heat energy can be categorized into latent and sensible heat, which connects with the various gas and fluids into that. So flow of liquids, vapors, this we will take into the next sessions. I mean, how further it flows, how things changes. But in short, I like to just recap how the air conditioning works. Air conditioning helps to absorb energy from a one part of or from a room and to reject energy into a different part, that is outside. If room is at a lower temperature and outside is at a higher temperature, naturally heat energy will not move from a lower temperature to higher temperature. So we need an external medium to carry the heat energy from lower to a higher temperature, and we need an external device because we will absorb energy, we will additionally increase the energy of that medium, then this medium is given, go outside, reject the heat, comes back and absorb more energy. So in our case, the refrigerant absorbs heat energy from the room, goes to the compressor, compressors add more heat energy into the refrigerant, which is more than the ambient temperatures. It goes to ambient temperature, then it gives the higher energy to the ambient temperature, the refrigerant. Then refrigerant comes back, it changes phases so that it can absorb more energy. It absorbs more energy from the room, then it goes back to the compressor. So this continuous flow of refrigerant helps to reduce the room temperature and maintain our desired temperature. Based on our requirement, the change of our temperature settings, the compressor works. Sometimes it can goes off if you don't need temperature. All this managing the flow of the refrigerant is the way how you control the air conditioning. So continuation to various types of air conditioning, usage of air conditioning and other thing we will take into the next session. So learning by looking around or known to unknown, that is what, see. So from making a coffee at your kitchen, we understand how the heat energy moves and how that principle is used in air conditioning. So now, like you asked a question about refrigerator, so I want you to look into one part. What happens if you keep the refrigerator door open? Will it cool the room? Will it heat the room, or what will happen? That is something which you can think about it. Think from a refrigeration the cycle or point of view what we explained. See what happens into that. That is one activity which you can do before the next class. And second thing is, there's a person who is known as the father of air conditioning. Air conditioning is almost 120 years old. What do you call the modern air conditioning or the mechanical air conditioning? Who is he? Which country he was there, and how he invented the air conditioning? It's a publicly available thing. Google it and understand about it. The person who has invented the air conditioning or the modern air conditioning. These two things, and maybe third is like you can just understand about what is the different kind of air conditioning into that. We don't touch in the refrigeration set, various type of air conditioning. What do you see when you move around? What do you see in the shopping malls where the cold air coming out? What do you see inside your home? or when you go into where the ice creams are kept, the refrigeration devices, just look around and see what kind of different kind of temperature controlled devices what you're seeing into that. So I'll just summarize. Air conditioning is all about managing the air, the properties of the air. We control or we adjust the properties of air as per our requirement. That is what does in air conditioning.
That how this mercury in one mercury rises when temperature rises in this thermometer.
So any mercury is a liquid. It's a liquid form. So when you increase the temperature, when you heat it, it expands, increase the volume. So what I explained to you, the pressure, volume, and temperature is proportionate. So when you increase the temperature, the volume increases. So in a thermometer, when you put into heat source, the mercury volume increases. So it has no way, it has given a channel to go. So it goes through that pipe and it increases because it cannot be contained inside the bulb where it is holding it. Same thing happens with water also, but water increase is very small. We will not be able to measure it. So mercury at a atmospheric pressure as a constant or proportionate increase of based on the temperature. So 0 to 100 degrees Celsius, it increases proportionately. That is the reason we use mercury thermometer. So say, if it say, for example, for every 1 degree Celsius, if mercury moves, say 1 millimeter, so 0 to 100 degrees Celsius, it goes by 100 millimeter. So that is the reason in thermometer, it is marked in line and it increases proportionately. So mercury thermometer can be used in certain range. When you increase the temperature, it increases the volume. When you reduce the temperature, when you put it into the ice, the volume reduces. So whatever is increased on the bulb, it comes back to the holding area of the bulb. So that is how the mercury thermometer is used, the principle behind the thermometer.
Sir, regarding that, what is the highest Celsius degree in a thermometer?
In thermometer?
Yeah, like 100 degrees Celsius. Is it more than that?
Mercury range, I don't remember. I need to check. I don't know. I'll check and let you know. I mean, I'll ask Satish to post in the group the
Yes.
range of mercury thermometer.
Okay.
No, I mean, I don't remember now.
Okay.
I have a question. Like, what was the traditional air conditioning technique?
Pardon me?
What are the traditional air conditioning techniques?
Traditional air conditioning technique is called evaporative cooling. That happens like if you have a mud pot, like kuja, what we call kuja. If you see the water inside that mud pot kuja, it remains colder than the water inside any other tumbler. So that is the traditional air conditioning, evaporative air conditioning. The water inside that mud pot, it comes through the mud, it gets evaporated outside. So when the water evaporates, it absorbs heat from inside. So the water inside the mud pot remains cooler. So this is the traditional air conditioning.
Sir, I actually have cold water like that.
Pardon me?
We have a mud pot in which there is a tap attached to it and we get cold water.
Yeah, so that is the traditional air conditioning method used. This traditional air conditioning method can be seen right from our origin of, you can say, history of mankind, from Egypt all the way to India. Many example, different ways of this is called evaporative cooling and movement of air. If you've been to the Thrissur temple, inside the temple, Sanctum Sanctorium, that is much colder than outside. So the air movement is balanced in that way. And the principle, what I say, when the air passes through a small orifice, it cools down. So air comes from behind and it rises up, and it passes through small orifices. The air remain inside is cooler. Or if you see old houses, the mud houses which has got a slanting roof into that, so the air comes through side and rises. The hot air will always is on the top and it expands. So all Kerala houses has got a slanting roof with a second layer covering above that, or it rises and there is a opening in the top. old way of construction. So air, large volume of air comes through the sides. It reduces the volume and passes through the small things. So the air movement increases. The below the air remains cooler. So there are way. This is the traditional way of maintaining the air conditioning. And I don't remember any other thing. The best example, if you don't see in India, which is very famous, is called Hawa Mahal in Jaipur. Hawa Mahal has got 900 plus windows. It's actually Hawa Mahal is 900 windows placed against the wind movement actually. So it placed in such a way the air comes, large quantity of air comes, it comes into a reduced volume and it comes outside inside area, and you stand there, you feel cooler. Jaipur, Rajasthan is a place which is very hot, but the air movement happens through the Hawa Mahal. Inside it is colder. And so this happens if you architect, when architect designs homes, you can see a large area which captures the air movement in the home and reduces the space. The volume will be at the air captures will be more, like our, you can see the front porch, and the small reduces and taken inside. So architect designs in natural way of maintaining air conditioning very well. So the principle applies is same, is hotter, is colder. You have to reduce the air movement, the volume where the air passes, it becomes colder. This is the natural way of maintaining air conditioning. You look around your old constructions, old means traditional constructions, you can see how the air is throttled to maintain the air conditioning in Kerala. All the way across the world, it is visible.
Yes, sir.
One more doubt, like what is the difference between temperature and heat and how they are related?
Temperature and
Heat.
Temperature and heat. Temperature is a unit, or temperature is a unit of measuring the heat. It's like it's a unit to express the heat, you can say. So like temperature, Kelvin, Celsius, there are various scales. The temperature is a theoretical notation of the heat, you can say, into that.
Okay,
Heat
thanks.
is a form of energy and temperature is a way of expressing it. And heat energy is measured in, we can say, in calories, kilowatts, and other things, in calculations and other things. And difference of energy for calculation, we use temperature as a way of measuring the heat.